Hello, my name is Darwin Murugarajan. I am from Group 5. So today me and my group members going to present our algebra project. So the topic that our team got is using determinant in real life application domain. So our first domain is solving 3D computer graphics. Imagine taking the familiar 2D coordinate grid x and y axis and adding a whole new dimension, that's a 3D coordinate system. It uses three numbers x, y and z to pinpoint any point in space, just like your address tells you on a map. Think of its a roadmap for the whole 3D world around you. The picture shows a 3D coordinate system. So a 3D coordinate system uses the three numbers called x, y, and z to represent each point. In the image, the z-axis is labeled z. There is also a point labeled P, A, B, C on the 3D coordinate system. So the point is located at A3 on x-axis, B2 on y-axis, and C1 on z-axis. Next is plotting coordinate on a cube. So as there is three axes which is x, y, and z. So every coordinate must consist of three numbers which will be represent every axis. So for example, for the coordinate A, the value will be 0, 4, 0. For coordinate B, 0, 4, 2. For coordinate C, 2, 4, 0. Coordinate D will be 2, 4, 2. Coordinate E will be 0, 0, 0. Coordinate F will be 0, 0, 2. Coordinate G will be 4, 0, 0. And finally, coordinate H will be 4, 0, 2. So next, we have already given the transformation matrix R, which is 1, 0, 0, 0, negative 1, 0, 0, 0, 1. So what we have to do is apply the matrix R to each of the vertices that we found just now. So the first one will be R times A, so the value will be 0, negative 4, 0. Second one is R times B, so the value will be 0, negative 4, 0. Third one is R times C, so the value will be 2, negative 4, 0. And the fifth one is R times D, so the value will be 4, negative 2, negative 4, 2. And the fifth one is R times E, so the value will be 0, 0, 0. For the sixth one is R times F, so value will be 0, 0, 2. The seventh one is R times G, the value is 4, 0, 0. And finally R times H will be 4, 0, 2. The next part is a plot of the cube after transformation. So this part you have to plot the every coordinate with their new value that we got by multiplying with the transformation matrix. So as you can see the picture, by comparing with the previous picture, the current cube will be rotated from the above to the down of the axis. So the determinant for this cube will be negative 1. So these are how they use determinant in a 3D computer graphics. So from the value, you can say that it's telling us that the reflection of the original cube and the volume of the cube is preserved.
Now we move to domain 2, solve electric circuit problem. So this is the method to solve electric circuit problems. The following is a general procedure for using merge or loop analysis method to solve electric circuit problems. The aim of the algorithm is to develop a metric system from equation found by applying KVL around loops or meshes in an electric circuit. Cramer rules is then used to solve an unknown mesh currents. Once the mesh currents are solved, normal circuit analysis method can then be used to find whatever circuit entity. So the solution is, this is the same example we have solved in exercise 7. We can see that there are three closed paths where we can apply KVL in loop 1, loop 2 and loop 3 as shown in figure 8.2. We can apply KVL around the loops remembering passive convention when defining current and voltages. So the KVL around ABCE loop is I1 times with R1 plus with I1 minus R3 times with R2 plus with I1 minus I2 times with R3 equals to V1. So therefore, I1 times with R1 plus R3 plus R2 plus R3 minus with I2 times with R3 minus I3 times with R2 equals to V1. So now we can create a matrix with that above equation as follow. So the following matrix is above with a value substitute 32, negative 10, negative 20, negative 10, 70, negative 5, negative 20, negative 5 and 27. And the answer for I1, I2, I3 is 15, negative 7 and 0. So solving determinant of matrix A, general matrix A from KVL equation, matrix A1, general matrix A with column 1 substitute by Y, matrix A2, general matrix A with column 2 substitute by Y, and matrix A3, general matrix A with column 3 substitute by Y. So as follows, the answer of determinant A is 2388, determinant A1 3920, determinant A2 2302, determinant A3 3330. So now we can use the solved determinants to arrive the solution for merged currents I1, I2 and I3 as follows. So the I1 equals to determinant A1 divided by determinant A. So the answer is 1.642A. The second one is I2, determinant A2 divided by determinant A. So the answer is 0.964A. Then the number 3 is I3, determinant A3 divided by determinant A. So the answer is 1.394A. So now we can solve the current R through R3 as follows. IR3 equals to I1 minus R2 equals to 0.678A. So the answer as we expected it to be, IR3 follows the direction of I1 as expected. Merge analysis and the nodal analysis gave equivalent answer.
Firstly, my name is Mukhtar Adan Osman and I'll be presenting Domain 3. Domain 3, the rotation in computer graphics by using determinant. Rotation objects are coordinate system in a 2D plan is a basic idea known as 2D rotation. This process allows us to change the direction of graphic elements around a definite point or axis using a specific angle. In order to carry out 2D rotation, two critical elements must be taken into account: the rotation angle and the rotation center. The rotation angle, symbolized as theta, measured in radius, indicates the degree of rotation to be implemented. Meanwhile, the rotation center expresses as Cx as Cy. Specific point about which the rotation is centered. The original coordinate of a point P, A, and B can be represented using standard trigonometry function. A is equals to R cos angle, B is equals to R sine angle. Point P, A, and B can be represented as follows. A is equals to R cos angle plus theta is equals to R cos angle cos theta minus R sine angle sine theta. B is equals to R sine B plus theta is equals to R cos angle sine theta plus sine angle cos theta. By replacing the equation represented as 1 and 2 into the respective equation 3 and 4, we derive the following expression: A is equals to x cos theta y minus y sine theta. B is equals to x sine theta plus y cos theta. Express it in measured from matrix from the equation mentioned above can be duplicated as following: AB is equals to AB cos theta sin theta minus sin theta cos theta, or B is equals to minus BR. When donating R as the ratio matrix, the equation can be represented in matrix from a following: R is equals to cos theta sin minus sin theta cos theta. For a positive rotation angle, the matrix presented above can be altered. However, in the scanner of the negative rotation angle, the corresponding matrix is to play it below. R is equals to cos minus theta, sine bracket minus theta, negative sine bracket minus theta, cos minus theta is equals to cos theta minus sine theta, sine theta, cos theta. Cos minus bracket minus theta is equals to cos theta and sine theta is equals to minus sine theta. Thank you.
Hello everyone, and my name is Darshan Kumar, son of Suresh, and my matrix number is CI230028. So I will be presenting the domain 4, which is use of determinants in civil engineering field. So the first one you can see here is in a construction endeavor, there is a task to install a retailing wall comprising concrete panels. To ensure the stability of the wall, the structural engineer is tasked with assessing the forces exerted on it. The illusion provided depicts the forces acting on a concrete panels, which you can see below, the P1, P2, P3. That is what we will call as the concrete panels. So each panel has a force applied at its top left corner, P1, P2, P3, as you saw in the pictures just now, and is subject to an external load. The forces acting on the panels are represented in matrix form as below, which we can see there. So determine the force P1, P2 and P3 acting on each concrete panel using determinants. So here is where we will see the solution, how to find the determinants. The matrix equation provided follows the structural Ax equal to B, where A stands for the coefficient of the matrix, X is the column vector containing the unknowns P1, P2 and P3, and B is the column vector located on the right hand side. As you can see below, which is the P1, P2, P3 is the column vector, and on the right hand side we can see that is what it is represented as B, which is a column vector located there. So the forces P1 and P1, P2 and P3 can be found using determinants, where we will apply the formula as below. P1 equals to determinant A1 divided by determinant A. So for the P2 is repeated as the same like the P1, which is determinant A2 divided by determinant A, and P3 determinant A3 divided by determinant A. So whatever determinants hence on the top, we will represent as A1, A2, A3, and the determinant below will be constant as determinant A for everything. So A1, A2 and A3 are matrices formed by substituting the respective columns of A with the column vector found on the right hand side. Okay, so here we can see how to calculate the determinants, determinant A1, A2, A3 and determinant A. Then use the formulas to find P1, P2 and P3 as we can see below. So the given matrix equation is determinant 3, -1, 0, -1, 4, -1, 0, -1, 3. So now we can see how to calculate the determinant of A. Here use the expansion formula as below and calculate the minus. So we will get the determinant of A is equal to 30. Now we can calculate the determinant of A1, which is determinant 50, -1, 0, -120, 4, -1, 80, -1, 3. So we will use the expansion formula as well as previously. So next we will calculate the minus, and we can get the determinant of A1 is 270. So for the next one, we will see now calculate the determinant of A2. So determinant 3, 50, 0, -1, -120, -1, 0, 80, 3. As same, we will use the expansion formula and we will calculate the minor, and I will get the determinant of A2 is -690. So followed by for the A3 as well, use the expansion formula and calculate the minus. We will get the determinant of A3 is 570. So now we will calculate for all the three P1, P2 and P3 as below. P1 determinant A1 divided by determinant A, which is 270 divided by 30 is equal to 9, and for P2 is -23, and for P3 is equal to 19. There the forces P1, P2 and P3 are approximately 9, -23
and 19 respectively. The negative sign for P2 indicates the direction of the force. So this is how I calculated using our manual form. And now next I will pass it to Lakshman to explain for the coding part. Thank you.
Good afternoon to the lecturer. My name is Lakshman, son of Nathan, CI2301119, which is my matric number. So previously my group mate Tarshan, which is explained the domain for use of determinants in civil engineering field, and also he explains a calculation which is in manual form. So now I'm going to do that question in a way of coding, and I must get the output as the same answer as Tarshan get in a manual calculation. So let's see the code that I create for this domain 4. So by utilizing the fourth real life application, we can generate C code that reproduces the output by simply computing the determinants. So beside, I attach the screenshot of my coding that I create for this project. I'll use an application called dev C++ for this coding. So this is the code that I create, and this is the continuous of that code. And let's see a few details about this code. The objective of this code is calculate forces P1, P2 and P3 in a 3D structure using a given matrix A and vector B. The overview of the code is the program calculates the forces based on the input matrix A and vector B. It utilizes the determinant of matrices to determine forces. The structure is the code defines functions to calculate the determinant of a 3 by 3 matrix and to calculate forces. The main function takes user input for matrix A and vector B. The user input is user provides values for matrix A 3 by 3 and vector B 3 by 1. The matrix operation is the code calculates the determinant of matrix A using the determinant function. It creates three matrices A1, A2, A3 by replacing column of A with vector B. The force calculation must be forces P1, P2 and P3 are calculated using determinants of A1, A2 and A3. The output of program should be prints the calculated forces of P1, P2, P3. The usage of this code is suitable for civil engineering applications to determine forces in a 3D structure. And lastly, the benefits utilizes mathematical principles to efficiently calculate forces, provides a foundation for analyzing complex structures. So this is the output. The program's output will prompt the user to input matrices A and B, calculate their determinants, and subsequently compute the force based on these determinants. So you can see the picture. I have attached an example output, the values for matrix A and the values for vector B. Lastly, the answer that I get, force for P1 is 9.00 and force for P2 negative 23 and force for P3 which is 19. So this answer is same as like Tarshan show in a manual calculation. So that's all for our group. Thank you, and thank you to the lecturer.